Hello, welcome to practice number 2, Metrology and Measurement. We're team number 1, and the objectives for this practice are: number 1, safety advisement; number 2, conventional measuring instrument used for the manufacturing industry; number 3, interpreting the results with the units that it corresponds; number 4, principles of the measurement; and number 5, knowing the equipment. In this practice, we're going to use a ruler, a compass, an analogical vernier, a digital vernier, and the micrometer.
Well, in this activity, we are going to divide our team in 3 operators. Each one is going to measure with different devices the external diameter, the internal diameter, and also the width of each bearing. So we need to know, first of all, what are these concepts. The external diameter is the distance far away from the center of the circle, and it needs to form a straight line between the edge and the edge that pass from this center of the circle. The same applies for the internal one, but we need to measure the distance from the smallest circle. So we have different devices like the scale ruler. With this, we are going to measure from this edge to this edge. So we need to adjust this line from the zero with this edge, and we need to read the second one of the right to get like approximately 3.4 centimeters, because we are working with centimeters, and we need to transform to millimeters to compare with the other ones. So we have approximately 34 millimeters. So the next one is the compass. With this compass, we also can measure these distances, but it's more specifically. So we only need to open the compass to adjust with the smallest one, and when we have the right measure, we only need to put in the scale rulers to support ourselves and to get the correct measurement, just like this one. And also we have 1.1 centimeters. We need to convert in millimeters to compare with the other elements. So we have 11 millimeters. So the next one is going to be explained by my mate Michael. So thank you.
This is the analog vernier. These edges work to measure the inner side, and this to the outer side. To measure a bearing, it works like you put it like this, and then you will calculate it, and it tells you that it is 31, and then you have to measure the decimals, and you have two bars. The low one is millimeter, and the up one is in inches. So we can see that there are 10 numbers, and then we have to choose the vertical one, which gets linear to the other bar. And in this case, we can see that it is 4, and it will be 31.4 millimeter. And then we can see this is a vernier, but the difference with this one, this is digital, and this tells you more precise. And when you start to use this, you have to make sure that this is calibrated at 0. So you press in here, and then you will see that it starts at 0. And then it depends if you want in inches or millimeter, you put in this. But it is like the other one. This is outer and this is inner. And then we have the micrometer, and this works to measure the width of the bearing. The other one is to measure the width, the large size and the short size. So we can see that the width of this one could be, well, it will depend on where you are, and in this case, if you are at 5, then you have to see the decimal, and the other ones you have to measure which one is at the vertical line. And the difference between this and the other, this is in inches, just inches. And you can see this one is 5 at 0.521 inches.
According to the results and the analysis that we performed of the results, what I'm going to show you is the measurements that we get as a team. So if you get closer, we can see that we had to fill tables related to the measurement of the big and small bearing, which each kind of the 5 instruments that we explained. So this is, we have person 1, person 2, person 3, external diameter, internal diameter, and width. According to the ruler, to the compass, to the analog vernier, the digital vernier, and according to the micrometer, only the width of the smallest bearing. So if you see these results, we can see that there's variation, right? Yes, according to each person and to each instrument. This is the dispersion of the results, and this is the average of the results, okay? So according to these numbers, we can conclude that the measurements were not the same. Some factors that may influence in this dispersion of the results may be the temperature, and, well, the 3 factors. The temperature, because of the contraction and expansion of the materials. For example, this is metal. Maybe the reproducibility. When each person measures the same thing, it gives variation, okay? And lastly, maybe the knowledge of each person in order to measure. Maybe one of us in the team didn't know how to use this, so the first time it's difficult. From all these 5 instruments that we presented, the one with most variation was the compass, okay? Well, this is because you have to measure, for example, the external diameter, you have to open it, right? Well, you measure the external diameter, and then you have to pass this to the ruler and compare. This was the one with the most variation.
We will use to measure the dimension of our pies it depends in the precision and in the dimension of our pies. For example, if we want to know the width of this piece, we will take the micrometer, because the width of this piece is between 25 millimeters. And in conclusion, we need to know the precision and the dimension.
What I conclude from this laboratory practice is that we have to keep in mind that in every measurement there is variation, and we have different instruments according to the precision. So according to the piece that we want to measure, we need to use well, we have to use maybe there's an instrument that is better than another. So that's what I conclude.
In this practice, I learned how to use properly different instruments that we can find here in the lab of mechanics, and then I can choose the best one to use in my project.
At practice, we can learn how to use the measurement of instrument, and the most precise was the vernier, the digital vernier, and this could be applied to our project.
Well, concluding this practice, I think that we need to use the most exactly measurement instrument to get the most exact result, to get a perfect engineer, and to do better the work.
In the precision of a measure, it depends in the environment and in the person or operator that is measure the device.
Concluded from this practice that measurement and precision is important for practical purposes. For example, if we want to manufacture something, maybe we want to take into consideration the tolerance of the piece that we want to make.
In general, in all the engineering industry, we need the most precise measurement system to be exact as possible.